everyone. This is Samarth, and today we'll be starting our real valued function. So, for the past few lectures, you might guys have heard about functions and what functions are. So, let's study them in detail, right? So, first of all, real value functions, as the definition says, that is a variable x from set x to set y is a correspondence that assigns to each number x in the set x exactly one number y in set y. So it's, as you can see, the definition is a bit complicated. So what we can understand by this definition is that there is only a single x for which there exists only a single y, right? So as the definition says that x assigns to each number x in set x exactly one number y in set y. So there is only a single y for a single x, right? So it does not have to repeat its value. So here you can see that x is our input, like is an input dom, like you can say a domain of the function, and y is our range. So by domain, what we mean by domain is that what input we are providing to the function. Like if we are putting f of one, so one would be our would be a value in the set of domain. And range is what is the output our function is given to us. So y is the output, as you can see. So now let's move to the next part. See, yeah, the domain of f is the set x, as it says. One just cutting it off. I wanted to underline. So this is the definition of domain. And y is the image of x under y. So yeah, image is the concept you can understand is that y is a function and it gives you an image of x. So a image of x in f would give you y. It is a standard parameter, right? So this is the basic definition that you can understand. And now there are two forms like implicit form and explicit form. So by definition, an implicit form is a form where y is not defined like in a standard format. Basically, you can see that in this equation, both x and y can be interchange their value as dependent and independent variable. So in implicit form, what we see is that y is the dependent variable and it is a function of x. But in explicit form, y is the independent variable and x is the dependent variable. So it changes the definition a bit. You see, in this we had it is representing the same equation but in different forms. The first form is an implicit form because here x is the independent variable and y is the dependent variable. But in the second equation, you can see that y is the independent variable and x is the dependent variable. Now you can write y as the function of x because we have been taking the value of x as the input variable. Okay. So now evaluating functions. So you can see that f of x has been evaluated as x squared plus 7 and f of minus 5 would give you f of minus 5 would give you minus 5 squared plus 7 and that would be 32. Now if we take f of b minus 1, so simply you'll get an equation. Similarly, the other parts have been shown. Now evaluating more functions. So if a function let's define a function f of x is equals to x squared plus 3x minus 2. And for f of x plus delta x minus fx upon delta x. So this is basically a short-term definition of f dash x. If you understand, let me make it a bit bolder. Yes, so this is f dash x when delta x tends to 0. So we try to calculate it. So x plus delta x whole square minus 3 of x plus delta x minus 2 subtracted from the definition of x itself and then upon delta x. And when you further solve the equation, you get this. And this becomes this equation. Okay. So now let's get some more questions into our system. So yeah, let's take one more question. If f of x is given to us as 7 minus 4, and then we have to calculate this. See, why are we calculating this again? Because this is more than often we calculate for f dash x. And it is very helpful while calculating the derivative of a function. If you guys are aware, what a derivative of a function is. So derivative of a function is basically a slope of that graph. So, for example, let's take this is the graph, and I have to calculate the derivative of this point. So, it is the slope of the graph at that particular point, and it is very has multiple uses in the future. You like in the future on the past, have you might have done derivative. So, it has very a lot of uses in the future. Now, calculation we get this, and this becomes a constant for us. Yeah, let's do another problem. It is simply putting up values and calculating it. It's not that tough. I hope you're like able to do this. Yeah, let's move on. This is also a good equation, but not that fun. Yeah, so let's talk about intervals. So functions, the brackets play an important role in functions, guys, because they have a role to depict. For example, if we take a curved bracket. So by curved bracket, we mean that we cannot include the values of a and b while calculating the function. So it is bounded, but it's an open interval. By open interval, what we mean is that we are not including the values that are in the boundaries, that is a and b. You can see there is not an equality sign here, right? So it is an bounded open interval. Now for bounded closed interval, you can see that we have been putting an equality sign here, and that means that we can take the values of a and b both for x. Okay, so bounded intervals, it is not neither open nor closed. So what happens is we can take a value of b or value of a at certain points, but not at all. Not both of the values are taken. Now, by unbounded, what we mean is unbounded means we have taken infinity into consideration. So if it is minus infinity to b, so what we get is we can take the values of x from minus infinity to b. And similarly, if it is a to infinity, it simply says that we can take the values of x from a to infinity. Yeah, so entire real line you might be aware of what a real line is. Yeah. So now talking about domain and range of a function. So domain of a function can be described implicitly or the domain can be described explicitly. Okay, so let's see what implicitly and explicitly mean here. So this equation has an implicitly defined domain that is a set of x. It cannot be equal to plus 2 minus 2. Okay. So why we cannot take plus 2 minus 2? Because at plus 2 minus 2, the function would go to infinity, and we do not want that. We never take a function's input where the function is going to infinity. So we don't take these values. And now explicit definition is fine. This explicitly defined is like it has already been mentioned by the person giving us the question. Because here X has been already defined for us 4 to 5. It is not like it has been explicitly mentioned, right? It is not that something we had to look upon. So we can get an explicit domain, and the range would be like this. Okay, so finding the domain and range. It is a very easy question, guys. Like this is very easy topic according to me. So what here the major points that you have to consider here that the function cannot go to minus infinity or infinity at any point. So we have to exclude those values of x such that f of x is not equal to infinity and minus infinity. Right. So also see in this question we have root of x minus 1. And we are aware that root does not take negative values, right? We can yeah. So root does not take negative values, right? So we have to ensure that x minus 1 is greater than 0. Or equality, we can put equality, so it has to be greater than equal to 1. Yeah, so the domain becomes x has to be greater than equal to 1. And the range is of course always positive. The range of root and maximum time is always positive. So 0 to infinity is the range. Also, we never put a square bracket over infinity because we're aware that we never reach infinity. Okay, so we can look more questions on domain and range. So first, this is a real domain for us because there is nothing over which your function would go to infinity. It can go to infinity, but not while dividing with a division of zero. It can go to infinity when will go to infinity, but not with a division of zero. So we have to ensure that f of x does not go to infinity or minus infinity with a division of zero, because that is not correct. We have a definition of a function being defined with zero. So we exclude those values from our functions domain. Calculating the range can be easily calculated. So this, you can see it is a parabola and it has two roots. This can be written as f minus 5 x of over. Okay, I'll just erase it everything in the chart. So let's see, the equation comes as f of minus 5 into x of plus 3. Right? X of minus 5 into x of plus 3 is equal to 0. So the roots are minus 3 and plus 5. So it would look like this. So we calculate for it. Yeah. So we calculate the range. So the range would be this point to infinity. That is exactly what we're trying to do here. Now calculating here, x cannot be equal to 7 because at 7 the function would go at to infinity by division of 0. And that is not defined in mathematics. So we'll try to exclude the domain from 7. Okay. So yes, functions being defined by more than one equation. Also, this is also very prevalent for JEE. Like if you're prepping for JEE, this is the question. These are the questions that you will see more often in your paper. So what we are trying to do here is we will try solving these kind of questions with graphs. See, plotting a function's graph, if you can draw a graph of function, can make the question very easier for you. If not, then you'll have to try solving it mathematically. But plotting a graph can like make your question very easy. For example, if you plot the graph of 1 minus x and root of x minus 1, it will easily tell you the domain and range of it. The range can easily be seen that the function is never going below 0. So its range is 0 to infinity. And the domain is of course real. Okay, so piece function, it is very similar to the question that we did earlier. So by piece function, what we mean is that it is not a continuous function. See here, the graphs were touching each other, right? So these were a continuous function, but here, the graphs necessarily might not touch each other. So these are piece functions. For example, if you take x0 for the first part, you get 1, and for the second part, you get as 2, which are exact both different values. So this is here, the domain would be real, but the range won't be real. Since these are the values that the function is not giving us. Now let's see the piece function, another piece function. Yeah, this is very similar to the last one, right? This is the same question, sorry guys. Yeah, let's move to the next. It's another piece function wherein the first piece is 3x minus 4, where x is less than 1. And the second is x square minus 8, where x is greater than minus 1. Okay, so we'll solve this up. And this is giving us a continuous graph. Let's calculate the value of f of x at minus 1. So what we get is minus 7 and minus 7. So it is a continuous graph. And we are saying that both of the values give the same value at minus 1. So we have to find the domain and range, right? Let's see. So these can be easily calculated. It's not that of a big deal. Domain is, yeah, as you can see, domain is minus infinity and range is also minus infinity. Yeah, so let's move to part B. Is it the same? Yeah, it is the same. So let's see a different function. There is not an happening. Yeah, this is the question, right? So we have a different question. No, it's the same question. No, there is a sign change. There is a sign change, but there is not. What is the deal here? Okay, so there is a change here. What the change is? This is the change here, guys. So this is something important that you have to learn. So here the range would change because both of the functions, one is going like this and one is going like this. Okay, so at this point, we have like, continuous, but it is not going below -7. So we will see the range is from -7 to infinity. Okay, this is the same question. No, it's not the same question. So we can see here that this is a piecewise function again, but which is has been cut at x is equal to 0. So at x is equal to 0, this gives us 7. This gives us 5. So these are both different values. We plot them. You can easily find the range also. This is giving us all the values. But we cannot see anything about 7, right? These are negative values are all included. So it is minus infinity to 7. Also, there should be a square bracket at 7. I don't know why there is not a square bracket at 7. There should be a square bracket at 7. Because there is an equality sign at x greater than equal to 0. And if we take x is equal to 0 here, so we get a value of 7, right? There should be a square bracket. Yeah, so let's see another function. How to find the domain. So the first part says that is less than equal to 8. But root says that root 2x, so 2x has to be greater than equal to 8. This would give us x greater than equal to 0 less than 8. This is our domain. And this gives us a real domain, so our domain becomes x less than equals to 8. Why minus, sorry, 0, 0, greater than equal to 0 and less than 8. So it is 0 to infinity with a close bracket, and the range is also similar. Let's see another question. So graphs of function. As I stated earlier, if you plot a graph of a function, the almost your job is done because the graph can tell you all the information. The mathematics cannot. So sometimes the graphs are really important. So let's see what kind of graphs are here. See, first we have an identity function which is just y is equals to x. You can check it out. Y is equals to x. This y is equals to x square, which is a parabola. It's a standard parabola. Then we have the cubic function. We have the square root function. These are standard functions. You have to remember the graph in these questions. Okay. Okay. Then we have the absolute value function. It is also a very important graph. Then we have the rational function. This would also, you will see cos and sine graphs are really important. Just a minute, I need to get back to the slide. Yes, so vertical line test. Yes, the vertical line test simply says that if a graph plotted is a function or not. So what does it state is that if you draw a vertical line on a graph, and if it intersects more than one point at the graph, it means it is not a function. Like it is not the correct answer for a function. So it is intersecting at more than one point. So this is not a function. Because by definition, there should only be a single y for a single x, right? So this is not a function. These are functions. Okay, transformation of functions. So transformation, what we mean is that if we are trying to shift the origin or trying to change the value of x, trying to change the value of x-axis or y-axis for us, so that can be easily understood. It's not something that is out of the world. But saying that transformation can really help you with questions. For example, there is a function given to us, f of x is equals to x minus 7 whole square plus x minus 7 plus 9. So here what you can do is take x minus 7 is equals to say variable t. And then what you get is x is equals to t plus 7. So you write f of t plus 7 is equal to t square. And this makes solving your question much easier. So let's see an example of transformation. So if the f graph is shown here, and we have to sketch the graph of each function. Okay. So see, if x is plus 3, right? So what we are doing is we are trying to shift the x-axis, y-axis here. If we are changing the value of input here, so what we're trying to do is was a graph here. So the new graph would look like this. Because at 0 this looks like this, but now at x plus 3, so you'll get the 0 value here. Am I correct? No, no, it's wrong. Okay. So if the original graph looks like this, तो x और 0 पे यहाँ पे था वो, तो अब जो नया ग्राफ होगा, लेट्स टेक अ डिफरेंट पेन, अगर नया ग्राफ होगा तो x ऑफ 0 पे वो यहाँ पे था, अब x ऑफ 0 पे वो 3 वाली वैल्यू पे होगा, से लेट्स से इट इज 3, वो यहाँ पे होगा. Yeah, so the this would be the new and this is the old. Get it? It is more easier if you like take 2 points on the graph and try to shift that key on the same value if it's giving us the same value or not. So it is very easy that you can draw it like that. Okay, so now let's get to the polynomial. So let's get to the polynomial part. So the polynomial states that polynomial functions are basically functions defined by this format. It is an important format that you can learn. It's not that tough. So what we do is we define a variable of n and take the power of x to n similarly. So it's a polynomial function. So by degree of a function, what we mean is the highest power of x that we have in the function. So if for example, if there's a cubic degree polynomial, so by cubic degree polynomial, what we mean is that the highest power of x in that function is 3, right? So these are the different definitions you can see that what is the leading coefficient, what is the constant term, what is the leading coefficient here. The second one is trying to like uh, mess you up and you might think that the leading coefficient is 2, but it is -6 because it is the it is the coefficient of the highest power of x. So it is the leading coefficient, right? Okay. So now turning points of the function. So how do we define turning points? So turning points are basically degree minus 1. It is a very simple question. If the degree is 5, there would be 4 turning points. If the degree is 3, then there are 2 turning points. Okay. So end behavior of functions. So the end behavior can be easily understood. It's not that complicated. So if a function is even function, so for example, if it is x square, x4, x6, so what you observe here is that if x goes to infinity, y would go to infinity. Similarly, if x goes to minus infinity, y would still go to infinity. So it is going always up, right? At both ends, it would go to infinity itself. So the function is an even function and the end behavior would be both of these ends would go to infinity. But in the case of odd functions, But in the case of odd function x, x cube, x5, you see that x goes to infinity, y goes to infinity. But x goes to minus infinity, y would also go to minus infinity. So it would look something like that. Here it goes to positive infinity, here it goes to minus infinity. Okay, these are very easy questions, and you can simply do that. Zeros of the function, it is very important that you know what are the zeros of the function. So by zeros of the function, what we mean is that when does y of x go to zero? Basically, if this is the graph, these are the zeros of the function. If this is the graph, these are the zeros of the function, right? So zeros of the functions are where the graph intersects the x-axis, or the y value is zero, or x of x equals to zero. These are the zeros of the functions, right? So what we can do here is, if we want to calculate the function, we can simply put f of x equals to zero. So in the first example, it was x minus 4, right? So one of the zero would be x is equal to 4. Let's take another example. Excuse me. It was x4 minus x2. So it is x squared, take x squared common. So here what we get is x equals to 0, 1, and minus 1. These are three zeros, right? Let's see the graph of it, guys. Let's see what is the graph of it. It is 1, minus 1, 0. So it would look somewhat like this. Okay, this would be the graph of the function. Okay, let's see odd and even functions. So what do you mean by odd and even functions? So odd functions are those functions. F of minus x gives you minus x is an odd function. And f of minus x gives you f of x is an even function. So the first example that comes to my mind is sine and cos. So if you take f of minus sine, this gives you minus sine. No, sine function is an odd function because f sine of x is sine of x, but sine of minus x is equals to minus sine x. So sine x is an odd function, right? Okay, so let's move to another question. So let's do some practice over odd and even functions. So odd and even functions look like. So let's take the example of first. So yeah, the first equation is 3 minus x4. So it is remaining the same. Here f of minus x is equals to f of x. So it is 1. Now let's do another question. Q of x equals to x to the power 2 by 3. So we can write this as root 3 x square, right? As the question stated. So if we take g of minus x, we get this. It is remaining the same, so it is again even. Because if we square off minus x squared, so minus gets cancelled and it remains the same. Here, you can see that it is x square sine x, right? So if I write f of minus x, I get is minus x square into sine of minus x. So this becomes x square and this becomes minus sine x. And this is equals to minus fx. So it's an odd function. I think you can do other examples by yourself. These might help you. And sometimes these easy questions can come in mains as well because they just simply ask you what is the value and you have to say it's an odd function or even function. So let's do some tough questions now. Okay. So we have a f of x. So these are a bit complicated questions. I'll try to solve for you. Let's see if we can do it or not. So we have, array. Okay, so this is our function. So this is our function, right? So it is given to us f of g of g of f. Let me erase it again. Let's write it. So it is given f g g of f of x is equals to g of f of x, right? So it's a very easy question. So let's take g of x is equals to p of x. Why not? P of x. So what we have is f of p of x is equals to p of x. And if we take p of x is equals to t, so what we get is f of t is equals to t, which is a linear line. And what is asked? What is the question asking us? Where did the question go? You can also calculate it. Yeah, it's simple only. So asking g of f of x. So f of gives us x square. G of x square would give us sine of x square. Then it would give me sine of x square. So it gives us g of f of x is equals to sine of x square. And this is already given to us. We have calculated these, right? So these are the two equations that we have to equate here. So let's equate these. And we can take out a single factor. We get sine x square is equal to 0 and sine x square is equal to pi by 2. So this cannot be a solution because sine is always everything from -1 to 1. So sine square is equal to pi by 2 is not an option. What we are left with is sine x square is equal to 0, which gives us x square is equal to n pi, and then x is equal to root of plus minus n pi. Where that is so easy to solve. The first thing what we did here was we tried directly putting the questions, the value to x in the functions. So it might look complicated here, but when you start writing and solving, you realize it's not that tough. Let's find the range of this. This is nice. So the question says if we have to find the range of f of x is equals to 3 sin x minus 2 cos x, right? Okay. Okay, so what we can do is we have to find the equation of these, right? So let's do one thing. Yeah, so see, this is positive, this is positive. So the maximum of minimum, the minimum of x would be when this is at its lowest, this is at its maximum. Okay. So when that can happen, so minimum of sin x is -1. But since it is in a like this function, the absolute function, the function of the value of the minimum value of an absolute function of x is 0 and the maximum is 1. So we can take those values off. And what we get is 3 of 0 minus 2 of 1. So this would give me -2. This is the minimum of the function. Now finding the max would be maximizing the sin x and minimizing the cos x. That can be easily done. And the max we get is 3. So the range becomes this. It was a comparatively easy question because here the range of sin x and cos x, the absolute value of sin, the absolute value, the absolute the range of absolute functions of sin x and cos x is 0 to 1. So these were all about positive range, right? So we can easily solve this question and get our values out of it. Let's take another question. Yeah, this is easy. Okay. So range of 7 minus x, p, x minus 3. So we know what np, sorry, n, right? What do you have to find? You have to find the range, right? Okay. So what they have done is very simple, right? This is a very nice way of calculating. This is interesting. So please remember this. When we are solving NPR and CPR questions, sorry, NPR and NCR, so there is a condition here that N is greater than 0, R is greater than 0, equal to also. Is there is equality? I don't think there is equality. I don't know what NC0 is, or do I? No, I do know because this is equals to 1. So we can take it as 0 also. And N is greater than equals to R. So let's apply those qualities. Greater than equal to 7 for x minus 3 greater than equal to, and the later gives f is equal to less than minus 5. So we have the values of x. So we can calculate the range equally. Let's move on to the next part of the question. Let's what I mean is by next question. Let's take another question. Okay, so this question might seem a bit new to you. What subjective, what injective means. So these are simpler definitions, right? So by subjective, what we mean by subjective is just a minute. I'll tell you what subjective is. Okay. So as we discussed earlier, what subjective and injective is. So subjective functions are onto functions. So by onto, what we mean is that there exists at least one element at x in the function's domain such that f of x is equals to y. So वापस let's repeat it. There is there is at least one x such that f of x is equals to y. And similarly, the vice versa is for injective. Injective means that there is at least a y in the range such that okay, so subjective, I think you guys understand. Let me draw a graph of it if possible, and I'll depict what. There's a very simple depiction that I just discovered. So let's see. This okay. So let this be subjective. This be non-subjective. This be injective. This be non-injective. Right. So this means 1, 2, 3, A, B, C. That every element in X has their image in Y. So this is right. Now let's take this 1, 2, 3. A, B, C, D. One, two, three, but D is not being sufficed here. And let's fix this. So it is A, B, C, one, two, three, four. One, two, three, four. So my 2 and 3 both are given B. So it is a non-injective function. Because for a Y, there exists two X's here, right? So it is non-injective. Similarly, for X and Y, one, two, three, it's a general function. It's not surjective, non-injective. So you can see the definition and look up more ways to solve these questions. What do you mean by definition of surjective and injective? But there is an easy method also that we can use for solving surjective and injective questions. That is the line method, right? There is something called as line method, which we use to calculate. Okay. So here you can see that, yeah, the definition, we were talking about the line method, right? So I'll tell you what the line method for calculating is. Line method for, okay. So for defining, if surjective, for surjective, we have the horizontal line method. That is, if this is the graph, and this method, you have to draw a line, and if it passes through more than 2 points, then the function is non-surjective. राइट अगर हमें अगर कोई ग्राफ दे रखा है और हमें उस पे बताना है कि इट्स अ सब्जेक्टिव ग्राफ और सब्जेक्टिव फंक्शन और नॉट सो व्हाट वी डू इज वी ड्रॉ हॉरिजॉन्टल लाइन and see if it's passing through more than 2 points, like more than 1 point, so it is a surjective function, non-surjective function. And if it passes through only 1 point, like if is the function like this, so it is passing through 1 point entirely, right? So this is a surjective function because the horizontal line is only passing through 1 point. And for injective, let's look for injective function. So for injective function, we have the vertical line test. If the vertical line is passing through only 1 point, then the function is injective. But if it is passing through 2 points or more than 1 point, so it is non-injective. Okay, now I think you must be clear what subjective injective means. So let's see the solution once. So we have given here x 1 by x square, right? So let's differentiate it for a minute and see what we get. So on differentiating, what we get is f dash x is equals to 1 minus x square, 1 plus x square whole square. Okay, so what we can see is this would go to zero. The differentiation, see, differentiation would go to zero at x is equals to 1 and x is equals to minus 1. So there is a maxima and minima there. And x is equals to 0 is 0. So minus 1 and 1. So at 1, what I get is 1. And at minus 1, oh, sorry, I get 1 by 2. At minus 1, I get minus 1 by 2. Okay, so let's see. Okay, let's do it again. So what I'm getting here is f dash of x is equals to 1 minus x square, 1 plus x square whole square. And here what is given to us that the range is real, right? Just a minute, guys. Let me see if I can plot the graph for you. Okay. So the graph, what we observe is that there has been a maxima and minima at -1 and 1. So if we double derivate it, so double derivation at 1 is negative. Let me write it clearly for you guys. So of 1 is negative, so it's the maxima, and double derivative -1 is positive, so it is a minima. So this is the graph that we see. Okay. So it is not passing the horizontal line test. So horizontal line test it's not passing, so it's not subjective. It is non-injective. Just a minute. So it is not subjective. I think that it is subjective. They have mentioned as the right answer, but it is not subjective because it is not passing the horizontal line test, right? No, it is subjective because at least एक बार को काटना होता है. अगर एक बार काट दिया हमने लाइन को तो subjective तो होगा. ठीक है. बट इंजेक्टिव नहीं होगा. इंजेक्टिव क्यों नहीं होगा? इंजेक्टिव होना चाहिए. इंजेक्टिव भी होगी उसमें हर हर जगह काट रहा है वो, सो इट्स नॉट इंजेक्टिव. So let's move on to the next question. I think we're out of questions right now. So let's do some questions that are mentioned. We can do this question. This question looks interesting. So what we have is it is given to us f of x is 1 by k into sin kx plus cos kx. Like these are k is in the power, right? So I think there is a mistake. It is f k. It should be. So let's try calculating this. 1 by 4 sin 4x plus cos 4x subtracted from 1 by 6 sin of 6x plus cos of 6. So this has been done. And now on subtracting, what we get is this. So we'll use the identities here that you might have learned earlier. So the identities are if a to the power 4 plus b to the power 4 is equals to a square plus b square. So whole square minus, this is a very easy identity that everyone might have learned. And why are we doing this? Because sine square of x plus cos square of x is equals to 1, right? So most of our problem would be solved then and there. So if you see that we put this identity into equation, so what we get is, excuse me, so what we get is 1 by 4 into 1 minus sine square x cos square x, and then 1 minus 6 into 1 by 6 into 1 minus 3 sine square x cos square x. And by definition, we also know that what are we supposed to calculate here? I think there is a mistake. I think it there is a mistake because it should give me the value of x to calculate f of 4 of x minus f of minus x. So there has been a mistake here. So let's leave this question. We can do this question if possible. So it is given to us f of x plus y is equal to f of x plus f of I. So we know that f of x is equal to kx. Okay. This is something that you learn from practice. So if this is given to us, f of 1 is equal to 7. So k gives me 7. And then I have to like sum it up, right? So summation of r is equals to 1 till n from f of r. So it is given to of r. Okay, f of r is kx, right? Sorry, f of x is equals to kx. So f of r is equals to kr and summation of kr from n to r. So k is a constant, so we can take it out, which is 7. Then summation of r from r is equals to 1 to n is 7 by 2 n into n plus 1. This is something that you again learn from experience. This is a very easy question, guys. I think we are done with questions. I can like give you one more question probably. Let's I think we are done with the questions. So if you have any doubts, please comment down. I'll try to solve those questions for you. But I think we are more than enough completed with the functions. Also, I tried to include the inverse functions in our previous lectures. So you can see more of it in the previous lectures. I don't think uh, there is much to it. If possible, I'll try to cover it in the next class, the inverse function part of it. But this was up for today.